So you see, this is example 4. And in the example, we are given that a 20 Newton horizontal force is acting on the handle of the socket wrench. And you see, we have to find the moment of this force about point P. So in order to find this moment, let's draw our position vector R between the points B and A. I would say we have to also find the coordinate direction angles alpha, beta, and gamma or the moment axis. So you see, this is the free body diagram. And you see, in this free body diagram, this 20 Newton force makes an angle of 60 degrees with y-axis. So in y-axis, we have the force component, and in the x-axis, we have the sine component. So this is our force, which is 20. And you see in the x-axis, we have sine 60. And in the y-axis, we have negative 460. And when we solve it, we get 17.32 in the x-axis and negative 10 in the y-axis. So this is Newton force. You see that the position vector R between the points B and A is minus 0.01 meter in the x-axis and 0.2 meters in the y-axis. So in order to find the movement of this force, let's uh, make a matrix. You see, when we take the determinant of this matrix, then we can find the movement. You see that when we take the determinant of point I, so it is 0, and at point it is also 0. So at point K, we get minus 3.36. And you see, this is our movement at point B, as it has a unit of about Newton meter. So we have to also find the coordinate direction angles. You see, when I take the unit vector of this moment, so I get minus 1. So you see that basically the angle alpha represents the x-axis. So at x-axis, the unit vector is 0, so we get cos inverse 0, which is 90, and same as with the angle beta. So this is also 90. And you see, as the gamma represents the z-axis, so the unit vector is about minus 1 in the z-axis. So when we solve cos inverse minus 1, so we get 108 degree, or is it at 108 degree.